We have been working on combining like terms to simplify algebraic expressions, and we're going to continue with that today, but we're going to look at it in the context of a geometry type of problem. So here's an example of what I'm talking about. This says, find the perimeter of a square with sides of 3x squared plus 4. Well, first let's talk about things that we know. We know that the word perimeter means the distance around something. And remember that the small word rim inside of the larger word perimeter reminds us of that. We're looking for the distance around the rim or the outside. And we know that it's a square, and if it's a square, we know that all four sides have to be congruent. So here's a hint also. Draw and label a picture of the square we're talking about. So if we do that, we're going to draw a square. Now, if it said that the side lengths were 8 yards, then we would label each of them 8 yards. But it doesn't say that. It says they have side lengths of 3x squared plus 4. So that means that this side is 3x squared plus 4. That means that this side is also 3x squared plus 4. And this side is 3x squared plus 4. And this side is 3x squared plus 4. Drawing the picture out really helps to make the problems make sense, because one thing some people try to do with this is they look at this and they say, okay, well, this side is 3x squared and this side is 4, and this is 3x squared. Well, that doesn't really make sense, because we know that in a square, all four sides have to be congruent. So they should all be labeled the same length. So this picture that I've drawn is the correct picture. So now if we want to find the perimeter, remember perimeter means the distance around. So that means that we want to add all four sides together. So we want to add 3x squared plus 4 plus 3x squared plus 4 plus 3x squared plus 4 plus 3x squared plus 4. And by lining it up like this, it has already grouped my like terms for me. So all of those plus 4s are going to make plus 16. And all of these 3x squareds are going to make 12x squared. 3x squared plus 3x squared plus 3x squared plus 3x squared is 12x squared. So my perimeter is 12x squared plus 16. And it would specifically be that number of square units. Or not square units, rather units. We're not doing area, it's just perimeter. So it's that many units. Now, thinking about this, I know that seems a little bit weird, but we can't know just a number answer because we don't know the value of x. If we knew the value of x, then we could plug in for the value of x and we could figure out the length of each side and add them, or we could have found the perimeter, which is 12x squared plus 16, and then plug in the x. And either way, you should get the same number if we knew what x was. Now, I want to also show you, some of you might have been saying, well, since all four sides are the same, couldn't we have done this as 4 times 3x squared plus 4? And yes, you absolutely could. And remember, that would tell you to do 4 times 3x squared plus 4 times 4. And that still gives us 12x squared plus 16. So either way you do it, you get 12x squared plus 16. Let's look at another example. This example says, what is the perimeter of a rectangle with sides of 5y plus 2 and 4y? So again, we're finding perimeter. Perimeter means distance around. So we want to draw a rectangle, and we want to label where they have side lengths of 5y squared and 4y. So that means one side is 5y squared plus 2, and the other one is 4y. So it doesn't particularly matter which side you label as which, but I'm going to label these two as 5y plus 2, and these two as 4y. Now that I've drawn and labeled my photo, this is my picture rather, this becomes really easy to find the perimeter, because I can do 5y plus 2 plus 5y plus 2. Notice how I'm going to line up the 4y's, plus 4y plus 4y. That allows me to group my like terms. I didn't line those 4y's over on the right under the 2's, because they're not like the 2's. So this makes it easy for me to do my, my addition. And if it helps you to put a +0 here so that you don't have empty space, you can certainly do that. So now that I've grouped my like terms, this is going to give me +4 here. And then 5y plus 5y is 10y, plus 4y is 14y, plus another 4y is 18y. So my perimeter equals 18y plus 4 units. Now, it would have been okay for you to do, some will say, well, could I just have multiplied 2 times 5y plus 2 plus 2 times 4y? And yes, certainly you could do that. But if you do that, you're going to get 2 times 5y plus 2 times 2 plus 2 times 4y is 8y, which would give you 10y plus 4 plus 8y. 10y plus 8y is 18y plus 4. So either way, I get the same answer. My perimeter is 18y plus 4 units. Next one, what is the perimeter of a regular hexagon with sides of 4 plus 7m? First of all, we need to know what a hexagon is, and second of all, we need to know what a regular hexagon. A hexagon is a polygon. Specifically, it's a polygon with 6 sides. So really, any shape that has 6 sides is a polygon. So 1, 2, 3, 4, 5, 6. That would be a polygon that with 6 sides, so that would be a hexagon. However, that's not the kind of hexagon we're talking about because it says we specifically are looking for a regular hexagon. That means a hexagon where all the sides and angles are congruent. So it's talking about one that looks like this, which is probably more like what you all thought of when you thought of a hexagon. So now I need to label the side lengths. The sides are 4m plus 7. So that means each side, or 4 plus 7m rather. So that means each side is 4 plus 7m. And if I want to find the perimeter of that, I can line it up like this: 4 plus 7m, 4 plus 7m, 4 plus 7m, 4 plus 7m. And I can do that repeated addition 6 times, or we know that repeated addition is the same thing as multiplication. So I could say, well, I need to do the 4 plus 7m, but I need to do it 6 times. And then I could use my distributive property to simplify that. So we could do 6 times 4 plus 6 times 7m. 6 times 4 is 24. 6 times 7m is 42m. So my perimeter is 24 plus 42m units. All right, take a moment and try this one on your own and see what you come up with. And then when you are done, pause while you're working on it. And when you're done, hit play and see if you were correct. So this is the figure that I would have drawn. And I can write this out as addition. So I can write 5x squared plus 6x plus 5x squared plus 6x plus, I would put the 4x under the 6x, 4x plus 2, and another 4x plus 2. I can add it that way. I can also, it's okay to do it this way, to go through and say, well, I see a 5x squared here and a 5x squared here, so that gives me 10x squared. My next set of like terms I see a 6 plus 6x plus 6x, 4x, and 4x. So that's going to make 4x plus 6x is 10x, plus 4x is 14x, plus 6x is 20x. So I get 10x squared plus 20x, and then my last terms that are like terms are the plus 2 and the other plus 2, which gives me a plus 4. So my perimeter in this case is 10x squared plus 20x plus 4. Now we can use this for all sorts of applications. We can do all sorts of things with this. We can even do something that looks like this. The perimeter of an isosceles triangle is 15x plus 6y plus 5. If the two congruent sides are each 4x plus 3y, what is the measure of the other side? Now this problem seems really hard till we draw it out, and that maybe hopefully makes it easier. So isosceles means two of the sides are congruent. So this is the kind of triangle that we're talking about. And it says the two congruent sides are each 4x plus 3y. And we're looking for the length of the other side. We know that the total perimeter has to be 15x plus 6y plus 5. Well, the sum of the two sides we know is 8x plus 6y. So I can find the side I don't know by doing this. 15x plus 6y plus 5. The total perimeter minus the 8x and the 6y, the sum of the two sides that I know. So notice we're going to get 5. The plus 6y and the 6y minus 6y is going to give me 0. And then 15x minus 8x is 7x. So that missing side must have been 7x plus 5. So keep in mind, we can do some of the same things with finding perimeter and even area if we were working on that with algebraic expressions, as we could do with whole numbers or fractions or decimals or whatever, as if we actually knew those dimensions. So we do it the exact same way. It's just that we're not going to get an answer that's just a number. Instead, we're going to get an answer that is an algebraic expression.